Look up at the night sky. On a clear night, away from the city lights, it can seem peaceful, orderly, eternal. We see the moon, a steadfast companion. We see the planets as wandering stars, following predictable paths. It all feels safe. But this feeling is a profound illusion. The solar system is not a peaceful celestial clockwork. It is a crime scene, a 4.6 billion-year-old story of unimaginable violence, cosmic billiards, breathtaking beauty, and profound mystery. What we see today are just the survivors of a chaotic and brutal past. The secrets aren't buried in ancient tombs on Earth. They are written across the faces of entire worlds. Today, we are not just going on a tour. We are detectives, piecing together the clues to unravel the 100 greatest secrets of our solar system. We'll discover a planet that shrank, a world that died, an ocean of unimaginable possibility, and a cosmic bodyguard that's also a cosmic sniper. By the end of this journey, the familiar map of our solar system will look very, very different. It will look like the beautiful, chaotic, and miraculous place it truly is. Let's start at the beginning, not just of our journey, but of everything. 4.5 billion years ago, there was no sun, no earth, no anything. Just a vast, cold cloud of gas and dust, the ghost of a long-dead star. Then, something disturbed it, perhaps the shockwave from a nearby supernova, and that disturbance began a process of collapse. Gravity took hold. As the cloud collapsed, it began to spin faster and faster, flattening into a disk, just like a spinning pizza dough. This was the solar nebula. At the center of this spinning disk, the pressure and temperature grew so immense that a star was born, our sun. And this is our first big secret. The sun contains 99.86% of all the matter in the entire solar system. Everything else, Jupiter, the Earth, you, me, every rock and speck of dust, is just the leftover rounding error. But it's in this leftover debris that the story gets interesting. Close to the young, hot sun, only rocky, metallic materials could survive the heat. These materials clumped together, first as pebbles, then boulders, then planetesimals, and finally, after millions of years of collisions, they formed the four rocky inner worlds: Mercury, Venus, Earth, and Mars. Farther out, beyond a point called the frost line, it was cold enough for ices like water, ammonia, and methane to freeze solid. This meant there was vastly more building material available, allowing the gas giants, Jupiter, Saturn, Uranus, and Neptune, to grow to colossal sizes. That's the neat, tidy story we're often told. A rocky inside, a gassy outside. Simple. Except the crime scene tells a different story. The early solar system was not a gentle construction site. It was a mosh pit. And the biggest brawler in that pit was Jupiter. One of the most mind-bending theories, known as the Grand Tack, suggests that Jupiter didn't form where it is today. It actually migrated inwards, blazing a trail of destruction through the inner solar system, almost to where Mars is now. This gravitational rampage scattered the building blocks of planets everywhere. It might be the reason Mars is so small. Jupiter essentially stole its lunch. Then, as Saturn formed, its own gravity pulled on Jupiter, and together they tacked, like a sailboat changing direction, and migrated back outwards to their current positions. Our solar system's entire layout might be the result of this ancient planetary dance. This chaos led to another period of sheer terror known as the Late Heavy Bombardment. For hundreds of millions of years, the newly formed planets were pelted by a relentless storm of asteroids and comets, debris scattered by the migrating giants. The scarred and cratered face of our moon is a perfect fossil of this violent era. Without this chaos, our world would be profoundly different. These comets, rich in ice, may have delivered the very water that now fills our oceans and the organic molecules that provided the building blocks for life. Our existence is owed to a cosmic storm. So, with this violent backdrop in mind, let's begin our investigation. Let's start our journey at the heart of it all, with the Sun's closest and most abused companion, Mercury. Mercury is a world of extremes. By day, its surface is hot enough to melt lead. By night, it plummets to temperatures colder than Antarctica. But its biggest secret lies deep inside. For a planet of its size, Mercury has a ridiculously oversized iron core, which makes up a staggering 85% of its radius. But the leading theory is that Mercury was once much larger. In the chaotic youth of the solar system, it likely suffered a cataclysmic, hit-and-run collision with another massive body. The impact was so violent it stripped away most of Mercury's rocky mantle and crust, leaving behind the dense, metal-rich heart we see today. And this giant iron core is cooling and contracting, which leads to another secret: Mercury is shrinking. Its surface is covered in massive cliffs called lobate scarps, which are essentially planetary wrinkles, formed as the entire world shrivels up like a drying apple. From this shrinking world, we journey outwards to a planet that should have been our twin, Venus. It's almost the same size as Earth, made of the same stuff, and is our closest planetary neighbor. But it is not our twin. It is our evil twin. Its surface temperature is over 460 degrees Celsius, 860 Fahrenheit, hotter than Mercury, even though it's twice as far from the Sun. Its atmosphere is 90 times thicker than Earth's, composed almost entirely of carbon dioxide, and it rains sulfuric acid. So what happened? The secret of Venus is a cautionary tale. It's believed that Venus once had oceans of liquid water, much like Earth. But being closer to the Sun, the water evaporated, filling the atmosphere with water vapor, a powerful greenhouse gas. This trapped more heat, which caused more water to evaporate, which trapped even more heat. It created a runaway greenhouse effect, a vicious cycle that boiled the oceans away and cooked the planet to death. So, next time you forget to recycle, just kidding, mostly. This brings us home to the only place in the universe we know for sure has life. But even our own world has a secret origin story, born from an act of unimaginable violence. Why is our moon so large compared to our planet? No other planet in the solar system has a single moon so proportionally massive. And why does Earth have its strange 23.5-degree tilt, which gives us our seasons? The answer lies in a cosmic collision. Shortly after Earth formed, it is thought that a Mars-sized world, which scientists have named Theia, delivered a body blow to our young planet. The impact was so powerful it vaporized Theia and blasted a huge portion of Earth's mantle into orbit. This ring of molten debris eventually coalesced to form our moon. The moon is not a captured object. It is bone of our bone, rock of our rock. And the force of that impact is what knocked our planet sideways, giving us the tilt that defines our climate and our lives. From our vibrant home, we move to the world that captures our imagination more than any other, Mars. The red planet. Today it is a cold, desert world with an atmosphere 100 times thinner than Earth's. But the evidence is everywhere. This world was once warm and wet. We see dried-up riverbeds, vast deltas, and minerals that could only have formed in the presence of liquid water. Mars once had rivers, lakes, and possibly even a shallow northern ocean. So where did it all go? That is Mars's greatest and most tragic secret. Unlike Earth, Mars doesn't have a strong global magnetic field. Without this shield, the Sun's solar wind has been blasting the planet for billions of years, slowly and relentlessly stripping its atmosphere away into space. As the atmosphere thinned, the pressure dropped until liquid water could no longer exist on the surface. It either froze into the soil or was lost to space forever. Mars is a world that died. A world that raises the chilling question: are we looking at a ghost of a once-living world? And could the same fate ever befall our own? That's a cliffhanger we have to put a pin in, because to understand what happened to Mars, and indeed the entire architecture of our solar system, we have to journey past the asteroid belt and meet the king. We have arrived at Jupiter. This planet is not just big, it's a paradigm shift. It is more than twice as massive as all the other planets, moons, and asteroids in the solar system combined. It is a failed star, made of the same hydrogen and helium as the Sun. And its role in our solar system is one of profound duality. On one hand, Jupiter is our bodyguard. Its immense gravity has absorbed or flung away countless comets and asteroids that would have otherwise struck Earth, potentially preventing extinction-level impacts. But it's also a cosmic sniper. Its gravity can also nudge asteroids out of the main belt and send them hurtling towards the inner solar system. It both protects and endangers us. But Jupiter's greatest secrets don't lie within the planet itself, but in the cord of moons that orbit it. It is its own mini-solar system. Its innermost large moon, Io, is the most volcanically active body in the entire solar system. It is a world of pure hellfire, with over 400 active volcanoes spewing sulfur into space. Because it's being tortured, Io is caught in a gravitational tug-of-war between the immense pull of Jupiter and the rhythmic tugs of its neighboring moons. This constant stretching and squeezing, called tidal heating, flexes the moon's interior like a squash ball, generating immense heat and powering its endless eruptions. But then, we move one moon out, to Europa. And here, we find perhaps the most tantalizing secret in the entire universe. Europa is a world covered in a shell of water ice, smooth and scarred with strange cracks. But multiple lines of evidence from its magnetic field and surface features tell us something incredible is hiding beneath that ice. A secret, hidden ocean of liquid salt water that may contain more liquid water than all of Earth's oceans combined, kept from freezing by that same tidal heating that tortures Io. Liquid water, the necessary chemical elements. A source of energy. It has all the ingredients for life. Could there really be life hiding in the dark, deep ocean of a moon, 1 billion kilometers from Earth? We'll leave that haunting question hanging in the dark as we journey to the most beautiful planet in the sky, Saturn. Everyone knows Saturn for its glorious rings. But here's the secret: they are a temporary wonder. The rings are almost entirely made of particles of water ice, ranging in size from dust grains to small houses. And they are pristine, bright, and clean. Too clean. If they were as old as the solar system, they would have been darkened and polluted by micrometeorite dust over billions of years. This suggests the rings are young, perhaps only 100 million years old. They may be the shattered remains of a large icy moon that strayed too close to Saturn and was ripped apart by its gravity. And they are disappearing. Material from the rings is constantly raining down onto Saturn, meaning in another 100 million years or so, they may be gone entirely. We are lucky enough to be living in the age of Saturn's glorious, but ephemeral beauty. And while you're marveling at the rings, don't forget to look at Saturn's North Pole, where you'll find another bizarre secret: a massive, stable, perfectly hexagonal storm, a six-sided jet stream wider than 2 Earths. We still have no idea how nature creates and maintains such a perfect geometric shape on such a colossal scale. It's just one of those things that makes you ask, is the universe just a little bit weird? Yes, it is. And if Saturn's rings tell a story of cosmic time, our next stops tell a story of cosmic violence. We arrive at Uranus. The secret of Uranus is obvious the moment you look at it. It's sideways. All the other planets in the solar system spin like tops as they orbit the sun. Uranus rolls like a ball. Its axis of rotation is tilted by a staggering 98 degrees. The only plausible explanation for this is another cosmic cataclysm in the distant past. A young Uranus was likely struck by an Earth-sized protoplanet, a collision so powerful it literally knocked the entire world over on its side. Now, it endures the strangest seasons in the solar system, with each pole facing the sun for 42 years of continuous daylight, followed by 42 years of absolute darkness. And finally, we reach the last of the gas giants, the beautiful blue world of Neptune. Neptune's secret isn't on the planet, but in how we found it. After Uranus was discovered, astronomers noticed it wasn't moving quite right. Its orbit was being perturbed by the gravity of something else, an unseen world lurking further out in the darkness. Two mathematicians, Urbain Le Verrier and John Couch-Adams, independently calculated the predicted position of this mystery planet based on nothing but Uranus's strange wobble. Le Verrier sent his calculations to the Berlin Observatory, and on the very first night they looked, they found Neptune within 1 degree of his predicted location. This is one of the most triumphant moments in the history of science. It was the first time a planet was discovered not with a telescope, but with the tip of a pen. It proved that the laws of physics are universal, and that science can be a kind of superpower. But our journey isn't over. We have crossed the realm of the planets, but the solar system keeps going. We now enter the Kuiper Belt, a vast, icy donut of trillions of leftover objects from the solar system's formation. And here we find the most famous resident, the king of the Kuiper Belt, Pluto. When the New Horizons spacecraft flew by in 2015, it revealed a world of stunning complexity. Pluto has vast plains of nitrogen ice, towering mountains of water ice, a thin blue atmosphere, and even possible cryovolcanoes that erupt icy slush. But its biggest secret is a giant, heart-shaped glacier on its surface, named Tomball Regio. This heart is not just a shape, it's a geologically active region, with its icy surface constantly churning and renewing itself. Pluto is not a dead, frozen rock. It is a dynamic, surprisingly active world that challenges everything we thought we knew about the cold, dark fringes of our solar system. And beyond the Kuiper Belt, the secrets continue. We now believe the solar system is encased in a final, mind-bogglingly huge sphere of trillions of icy bodies, known as the Oort cloud. It's a spherical shell of comets that extends almost a light year away from the Sun, a quarter of the way to the next star. These are the most pristine, untouched relics of the solar nebula from which we were born. Every now and then, a gravitational nudge from a passing star sends one of these icy fossils on a long journey inwards, where we see it as a beautiful, long-period comet. They are messengers from the dawn of our own creation. So, we have journeyed from a shrinking world to a sideways world, from a volcanic hell to a potential ocean paradise. We've seen how a chaotic past of migrating giants and relentless bombardment shaped the very worlds we see today. The greatest secret of our solar system is that it's not a collection of objects, but a single, interconnected story. The gravity of Jupiter dictates the size of Mars. The death of an ancient moon creates the rings of Saturn. A cosmic collision on Earth gives us our moon and our seasons. Every world is a clue, every crater a paragraph in a 4.6 billion year old epic. And the most exciting secret of all? It's that for every mystery we solve, we uncover a dozen more, waiting to be explored. The story isn't over. In fact, it's just getting started. And if you believe that the universe is the greatest story ever told, and you want to be there as we continue to turn the pages, then take a moment to subscribe and turn on notifications. Every click helps us continue this incredible journey together. And if this story blew your mind, share it with someone who you think needs to see just how amazing our cosmic neighborhood really is. Thank you for being a detective with us today. Keep looking up. Let's begin in a place we briefly flew past, the main asteroid belt. Now, what do you picture when you hear asteroid belt? Probably a scene from a sci-fi movie, right? A dense, impassable field of tumbling rocks that requires incredible piloting skills to navigate. Well, here's a secret. That's a complete myth. Space is just unbelievably big. While there are millions of asteroids in the belt, they are spread out over such a vast volume that the average distance between any two is over 1,000,000 kilometers. You could fly through it blindfolded and have virtually zero chance of hitting anything. In fact, every single probe we have ever sent to the outer solar system has passed through it without incident. But the belt holds a different kind of secret. It's not just a collection of rocks, it's a graveyard of would-be planets. This is the region of the solar system where a planet should have formed, but Jupiter's immense gravity constantly stirred up the material, preventing it from ever clumping together. It's a fossil record of planetary failure. But among the millions of failed projects, there is one that partially succeeded. We find the largest object in the belt, a world so large it pulled itself into a sphere, the dwarf planet Ceres. And Ceres is hiding something spectacular. When NASA's Dawn spacecraft arrived, it saw mysterious, brilliantly bright spots shining from the bottoms of craters. What were they? The answer is salt deposits, left behind after salty water from beneath the surface sublimated into space. Ceres isn't just a rock, it's a dormant ocean world. Scientists now believe it holds a vast reservoir of briny water beneath its crust. There's an ocean hiding in plain sight in the middle of the asteroid belt. Think about that for a second. The line between a barren asteroid and a world with the ingredients for life is blurrier than we ever imagined. While asteroids are the rocky remnants of the inner solar system, their icy cousins, comets, are the true time capsules. These dirty snowballs are pristine, frozen relics from the dawn of our solar system, born in the cold outer regions. For billions of years, they have drifted in the Kuiper Belt and Oort cloud unchanged. When one is nudged onto a path towards the sun, it awakens. The sun's heat vaporizes its ices, creating a glowing atmosphere, or coma, and two beautiful tails. One is a dust tail, which is yellowish-white and curves along the comet's orbit. The other is a plasma tail made of ionized gas, which is pushed directly away from the sun by the solar wind, often appearing blue. For centuries, they were just beautiful objects to be observed. But we wanted to know their secrets up close. The European Space Agency's Rosetta mission was one of the most audacious feats of exploration ever attempted. After a 10-year journey chasing Comet 67P across the solar system, it didn't just fly by. It went into orbit around the comet's tiny, rubber duck-shaped nucleus. It then deployed a lander named Philae to touch down on the surface. We didn't just visit a comet, we lived with one. And the secrets it revealed were profound. It found complex organic molecules, the building blocks of life, confirming that comets could have seeded the early Earth. It also found that the water on the comet had a different chemical fingerprint than the water in our oceans, suggesting that while comets contributed, much of our water may have come from asteroids instead. The discovery of Ceres, a dwarf planet in the asteroid belt, brings us to the rest of its kind, the controversial characters of the solar system. The discovery of Eris in 2005, a Kuiper Belt object even more massive than Pluto, is what triggered the whole "is Pluto a planet?" debate. Eris was the troublemaker, the world that forced us to redefine what a planet is. And now we know of a whole family of these distant worlds: Makemake, Haumea, Sedna. Each one is a unique, frozen kingdom with its own story. Haumea, for instance, spins so fast, a full rotation in just 4 hours, that it has been flung into the shape of a flattened egg, and it even has its own tiny ring system. These aren't just objects, They are the chieftains of the solar system's distant, icy frontier. Now, we've met the planets and we've met the smaller players. But what about the moons? We've already seen the volcanic horror of Io and the oceanic promise of Europa. But with over 290 moons confirmed in our solar system, you just know there have to be some other absolute weirdos out there. And you would be right. Let's return to Saturn. While its rings are spectacular, its collection of moons is arguably even more fascinating. And one of them, Enceladus, might just be the most exciting world we know of. It's a small, bright white, icy moon, only about 500 kilometers across. But at its south pole, something incredible is happening. The Cassini spacecraft discovered gigantic plumes, geysers of water ice and vapor erupting from massive cracks in the surface, dubbed tiger stripes, and shooting hundreds of kilometers into space. But wait, it gets weirder. Cassini was brave enough to fly through these plumes. It tasted them, and it found not just water, but salt, silica sand, and complex organic molecules. What does this mean? The salt tells us the water is coming from a liquid saltwater ocean. The silica sand is a smoking gun for hydrothermal vents on that ocean's floor, places where superheated, mineral-rich water is jetting up from the moon's rocky core. And the organic molecules are the building blocks of life. Enceladus isn't just an ocean world like Europa. It's an ocean world that is actively spraying its secrets into space for us to sample. Could these plumes contain the first definitive evidence of extraterrestrial life? It is, right now, the most accessible place in the entire universe to search for an answer. And as if one incredible moon weren't enough, Saturn has another, Titan. Titan is a monster of a moon larger than the planet Mercury. And its secret is that it's a bizarro Earth. It is the only moon in our solar system with a thick, substantial atmosphere, even thicker than our own. And under its thick orange haze, it has a complete liquid cycle, just like Earth. It has rain, rivers, lakes, and seas. But on Titan, where the surface temperature is a frigid minus 179 Celsius, the liquid isn't water. It's liquid methane and ethane, essentially liquid natural gas. Titan has mountains made of water ice as hard as rock and dunes made of hydrocarbon sand. It rains rocket fuel. NASA's Huygens probe, which landed on Titan in 2005, sent back the only images we have from the surface of a world in the outer solar system. They show a frozen, alien shoreline littered with what look like river rocks, but are actually rounded chunks of water ice. It is a hauntingly familiar, yet profoundly alien world. Let's leap across the solar system to the realm of Neptune and meet its largest moon, Triton. Triton is a rogue. It is the only large moon in the solar system that orbits its planet backwards, in what's called a retrograde orbit. This is a dead giveaway that Triton did not form with Neptune. It was a dwarf planet, like Pluto, that once orbited the Sun on its own, but strayed too close and was captured by Neptune's gravity. The process of being captured would have been incredibly violent, disrupting any existing moons Neptune had and melting Triton's interior. Today, it is one of the coldest objects in the solar system, but it is not dead. The Voyager 2 spacecraft saw active geysers of nitrogen gas erupting from its surface, creating dark streaks on its cantaloupe-like terrain. Triton is a captured wanderer from the Kuiper Belt, a world with a violent past and a dramatic future. Its orbit is decaying, and in a few 100 million years, it will drift too close to Neptune and be torn apart, likely giving the planet a spectacular ring system that would rival Saturn's. From a captured rogue, we go to a reassembled mess. Let's travel to the strangest moon of all, Uranus's moon Miranda. When Voyager 2 flew past, it sent back pictures that left scientists speechless. Miranda's surface looks like it was smashed to pieces and then haphazardly glued back together by a toddler. It has old, cratered regions right next to bizarre, deep-grooved canyons and towering cliffs. One of its cliffs, Verona Rupees, is the tallest in the solar system, over 20 kilometers high. A fall from the top, in Miranda's low gravity, would take you over 12 minutes to reach the bottom. The leading theory is that Miranda was shattered by a massive impact in its past, but the pieces didn't fly apart. Instead, gravity slowly pulled them back together into the jumbled, Frankenstein's monster of a world we see today. The stories of these moons show that the solar system isn't just about planets. It's about the complex, dynamic systems they command. But all of this chaos, from the weather on Titan to the geysers on Triton, is driven by invisible forces. Let's talk about extreme weather. We know Jupiter's Great Red Spot is a giant storm, but data from the Juno spacecraft has revealed its true, monstrous nature. It's not a surface feature. Its roots plunge at least 300 kilometers deep into the planet's atmosphere. It's a storm with the depth of a continent, and the winds at its edge scream at over 400 kilometers per hour. But if you think that's fast, travel to Neptune. Despite being the farthest planet from the sun's heat, Neptune has the fastest winds in the solar system, reaching supersonic speeds of over 2,000 kilometers per hour. How a world so cold and so far from the sun can generate that much energy is one of the great, unsolved meteorological mysteries. And all of this weather is influenced by the sun's constant breath, the solar wind. To study it, we've done something insane. We've touched the sun. NASA's Parker Solar Probe is the fastest object ever built by humanity. It is repeatedly flying through the sun's outer atmosphere, the corona, enduring temperatures that would vaporize any other spacecraft. It is designed to solve the mystery of why the corona is so much hotter than the surface, and to understand how the solar wind is accelerated. It's a mission of pure guts, flying into the belly of the beast to understand the force that shapes our entire solar system. But the most fundamental invisible force is gravity. And it does more than just keep planets in orbit. It creates points of perfect stability. In the 18th century, a mathematician named Joseph Louis Lagrange calculated that in any two-body system, like the sun and a planet, there are 5 special points where the gravitational forces and the orbital motion balance out perfectly. An object placed at one of these Lagrange points will stay there. These are the parking spots of the solar system. 2 of them, L4 and L5, are incredibly stable. Jupiter has collected over 12,000 asteroids in its L4 and L5 points, known as the Trojan asteroids. Earth has its own Trojan asteroid, and we've even started using these points ourselves. The James Webb Space Telescope doesn't orbit the Earth. It orbits the Sun at the second Lagrange point, or L2, a million miles away, where it can stay cool and maintain a perfect view of the cosmos. We have journeyed from the smallest rocks to the biggest storms, from captured moons to invisible forces. And all of this brings us to the final, great mysteries. What else is lurking out there? The strange, clustered orbits of several distant Kuiper Belt objects suggest they are being shepherded by the gravity of something huge, something we haven't seen yet. This has led to the tantalizing hypothesis of a Planet 9, a potential ice giant, perhaps 10 times the mass of Earth, lurking in the dark, far beyond Pluto. The hunt is on. Astronomers are scanning the skies, just like they did to find Neptune, trying to find the gravitational puppet master of the outer solar system. And then there's the biggest question of all, the one that drives so much of our exploration. Are we alone? The discoveries of the oceans on Europa and Enceladus have transformed this question from a philosophical dream to a testable scientific hypothesis. Upcoming missions like the Europa Clipper will be equipped with ice-penetrating radar to map these hidden oceans and search for the most promising places to look for life. The story of our solar system is a story of constant discovery. It is a 4.6 billion-year-old epic that is still being written. From the tiniest moon to the largest planet, Every world holds a piece of the puzzle. They are archives of a shared history, filled with violence, transformation, and the enduring possibility that even in the cold darkness of space, life might find a way. The greatest secret is that the adventure has only just begun. The solar system is not a static diorama. It is a living, breathing entity, constantly changing on timescales that dwarf human comprehension. The secrets we are about to uncover are not written in stone, but in the slow, inexorable processes of creation and destruction. We will look back to the very first moments of our cosmic neighborhood and forward to its ultimate, fiery demise. We'll explore the bizarre ways planets talk to each other, the colors you can't see, and the human fingerprints we are now leaving on other worlds. This is the final chapter of our investigation. The secrets of yesterday, today, and tomorrow. Let's begin by rewinding the clock. Not just millions of years, but billions. We know the planets formed from a spinning disk of gas and dust, but how do we know what that disk was made of? The secret is hidden in the oldest objects we can touch, meteorites. These aren't just rocks from space, they are time travelers. Specifically, a type called carbonaceous chondrites. These meteorites are pristine, unaltered samples of the original solar nebula, the raw material from which everything was built. They contain tiny, calcium-rich inclusions that are the first solid materials to have condensed out of the cloud, dating back 4.567 billion years. When you hold one of these in your hand, you are literally touching the stuff of creation, the building blocks of every planet, including our own. But this ancient material wasn't just rock and ice. It was radioactive. Elements like aluminum-26, forged in the heart of a nearby star that died just before our solar system was born, were seeded into the nebula. This radioactive material acted like a planetary heating system. The decay of these elements generated a tremendous amount of heat from the inside out, melting the interiors of early planetesimals and allowing heavy materials like iron to sink to their cores and lighter materials to form their crusts. Without the ghost of that long-dead star providing the initial spark, the worlds of our solar system might have been cold, undifferentiated lumps of rock and ice. Now let's fast forward to today and look at the solar system not with our eyes, but with a different kind of vision. Our eyes can only see a tiny sliver of the electromagnetic spectrum, but the universe is communicating in a symphony of invisible light. If we look at Jupiter in the ultraviolet, we see its spectacular, permanent auroras, hundreds of times more powerful than our own, glowing beacons marking the poles of its monstrous magnetic field. If we look at the sun in X-rays, its calm, friendly face transforms into a roiling, magnetic inferno of flares and hot spots. And if we look with the infrared eyes of the James Webb Space Telescope, the universe transforms. The thick dust clouds that hide star-forming regions in visible light become transparent, revealing the birth of new solar systems. The hazy atmosphere of Titan, a world we've visited before, can be pierced, revealing weather patterns and the geography of its methane seas in stunning detail. The secret is that what we see is only a tiny fraction of what is actually happening. To truly understand the solar system, we have to learn to see the invisible. This invisible universe also includes sound, or rather, the lack of it. But if we could translate the electromagnetic emissions of planets into audio, they would have a voice. NASA has recorded the radio waves generated by planetary magnetospheres interacting with the solar wind. Saturn sounds like a chorus of eerie, whistling alien birds. Jupiter sounds like the crackling, crashing waves of a chaotic cosmic ocean. These are the sounds of planets breathing, their magnetic fields singing as they protect them from the harshness of space. But the planets don't just sing into the void, they talk to each other. We've already discussed how Jupiter's gravity shaped the asteroid belt and the size of Mars. But the interactions are even more subtle and profound. Over millions of years, the slight gravitational tugs of the planets on each other cause their orbits to slowly change, wobble, and stretch in complex, quasi-periodic cycles known as Milankovitch cycles. For Earth, these cycles, the stretch of our orbit, the wobble of our axis, and the change in our tilt, alter the amount of solar radiation we receive. These subtle gravitational whispers from our neighbors are the primary pacemaker of Earth's ice ages. The climate of our world is, in part, dictated by a long, slow conversation with Jupiter and Saturn. And this conversation is not always gentle. Sometimes worlds collide. We know Earth was struck by Theia to form the Moon, and Mercury was likely stripped of its mantle. But we can see the evidence of these cosmic brawls everywhere. Saturn's moon Iapetus has a bizarre, equatorial ridge that makes it look like a walnut. One theory is that it once had its own ring system, which collapsed onto its equator, creating the ridge. Another is that it was struck so hard it nearly cracked in half. We've seen the Frankenstein's monster of a moon, Miranda. The entire solar system is a gallery of battle scars, a constant reminder that stability is the exception, not the rule. So, where is the most stable place in the solar system? That's a trick question. The answer is, nowhere is truly stable forever. But for the short term, our own world has a surprising secret guardian that makes it much more stable than it should be. Our oversized moon. The moon's gravitational pull on Earth's equatorial bulge acts like a stabilizing hand, preventing our planet's axial tilt from wobbling chaotically. Mars, without a large moon, has seen its tilt vary wildly from 10 to 60 degrees over millions of years, causing catastrophic climate shifts. Our moon is the reason our seasons are predictable and our climate is relatively stable over long periods. Without it, life on Earth might have had a much harder time getting a foothold. It's not just a pretty light in the sky, it's our anchor in the cosmos. But now, a new force is at play in the solar system. A force that has only emerged in the last tiny fraction of a cosmic second. For 4.6 billion years, the solar system has evolved according to the laws of physics alone. Now, for the first time, a species from one of its worlds has begun to alter it. The secret is that the solar system is no longer pristine. We have left our fingerprints everywhere. We have crashed spacecraft into the Moon, Venus, Mars, Jupiter, and Mercury. We have left behind rovers on Mars that will likely remain there for millions of years, slowly being covered by red dust, silent, human-made fossils. There are now over 100 million pieces of human-made debris orbiting the Earth, from dead satellites to flecks of paint, creating a dangerous and ever-growing cloud of space junk. And on the Moon, we have left more than just footprints and flags. We've left behind family photos, golf balls, and even bags of human waste. Future alien archaeologists are going to be very confused. This marks a profound transition. We are no longer just passive observers of the cosmic drama. We are now actors on the stage. And our role is only going to grow. We have plans to return humans to the Moon, to build permanent bases, and eventually, to take the giant leap to Mars. The question of whether we can become a multi-planet species is one of the defining challenges of our time. Can we carry the fragile spark of life that began here and plant it on another world? The answer will define the future of our species and the future of the solar system itself. And this brings us to the final act of our story, the deep future. What happens to our solar system in the end? As we learned in our journey to the Sun, our star is not eternal. In about 1 billion years, the Sun's brightness will have increased to the point where it will trigger a runaway greenhouse effect on Earth, just like the one that killed Venus. Our oceans will boil away. Life on Earth will be extinguished. Our world, for all its beauty and complexity, has an expiration date. In 5 billion years, the Sun will swell into a red giant. It will consume Mercury and Venus. It may or may not consume the Earth, but it will certainly render it a molten ball of rock. The habitable zone, the region where liquid water can exist, will migrate outwards. For a brief, glorious period, the icy moons of Jupiter and Saturn, like Europa and Titan, will be warmed to Earth-like temperatures. Their icy surfaces will melt, revealing the global oceans beneath. These moons will become, for a time, the most valuable real estate in the solar system. Could life, which may have been hiding in their deep oceans for billions of years, finally flourish on their sun-drenched surfaces? It's a tantalizing, beautiful possibility. But this, too, will be temporary. The Sun will eventually shed its outer layers as a planetary nebula and shrink into a white dwarf. The surviving planets and moons will now orbit a tiny, dim, Earth-sized stellar ember. Jupiter and Saturn will still be there, cold giants in the faint twilight. The charred cinder of Earth may still be there, a silent, frozen tomb. The solar system will become a cold, dark, and quiet place. And it will stay that way for trillions upon trillions of years, until the white dwarf finally fades to black. This is the ultimate secret of our solar system. It is not permanent. It is a temporary arrangement, a fleeting 4.6 billion-year-old masterpiece, born from the dust of a dead star that will one day fade back into the darkness. But this shouldn't be a source of sadness. It should be a source of profound appreciation. It means that what we have right here, right now, is precious beyond measure. We live in the brief, warm morning of our solar system's life. We are the lucky ones. We are the universe's way of knowing itself. We are the consciousness that has emerged on this small, blue world, capable of looking out at the cosmic crime scene, piecing together the clues, and understanding the incredible story of our own origins. The final secret is you. Your curiosity, your ability to wonder, is the most remarkable thing in the entire solar system. The investigation never truly ends. There is always another world to explore, another mystery to solve. And if you want to continue being a part of this grand detective story, then make sure you're subscribed, because our journey is far from over. Share this with anyone who you think needs a reminder of just how magnificent and precious our tiny corner of the universe is. Thank you for exploring with us. Thank you for wondering.